What is artificial intelligence? This technology term refers to the ability of a computer to perform tasks, usually associated with humans. One artificial intelligence example is the ability for computers to learn a highly complicated cognitive function which mimics the human mind. In machine learning, a computer can learn data such as medical image pattern recognition without even being programmed. Over the past few years, researchers have been working to apply artificial intelligence to the field of gastroenterology with great success. Now, colorectal cancer is the second leading cause of cancer death in the United States. And as gastroenterologists, we are excited to potentially use the power of artificial intelligence to help us with image analysis during colonoscopies to help identify polyps. Computer-aided detection software is being used to improve adenoma polyp detection rates. By removing these polyps during colonoscopy procedures, we can prevent colon cancer in our patients. The FDA recently approved a really cool technology called GI Genius, which is an AI machine learning program that aids in polyp detection in real time with a tiny square box hiding the polyp, kind of like those radars locked onto military targets in airplane movies such as Top Gun. AI can be used to find both malignant lesions and pre-malignant lesions. A recent meta-analysis including 5 randomized controlled trials and 4,311 patients showed that the adenoma detection rate was much better using a combination of computer-aided detection software with colonoscopy at 29.6% compared to colonoscopy alone at 19.3%. Computer-aided detection with colonoscopy can also improve the detection of tiny or diminutive polyps that were less than 5 millimeters in size. What about using AI in the esophagus and the stomach? Well, we've also shown that AI can help gastroenterologists detect dysplasia, esophageal cancer, and gastric cancers when using EGDs or upper scopes, a scope we use to look in the patient's esophagus and the stomach. Liver disease causes 2 million deaths worldwide, and the prevalence of non-alcoholic fatty liver disease, or NAFLD, is 25%. We've also been using AI to help make liver diagnoses for several years using ultrasound technology to help analyze the severity of fatty liver disease and to determine the stage of liver fibrosis. And AI can help radiologists and gastroenterologists interpret ultrasound images and differentiate between benign liver lesions and liver cancer. This is important because of the potential element of human error caused by exhaustion from reading a high volume of images or from challenges with interpretation. Currently, we are using AI algorithms such as traditional machine learning and deep learning. These are really important AI applications because ultrasound is so widely available and really inexpensive. Radiomix is a kind of machine learning that is popular in CT, MRI, and ultrasound. This artificial intelligence and imaging can help physicians identify complicated patterns that are difficult to recognize with the human eye. Machine learning has also been used to distinguish ulcerative colitis from Crohn's disease in pediatric patients. Artificial neural network has also been used to predict how frequently patients with inflammatory bowel disease are going to flare with a pretty high level of accuracy by analyzing data from our health records. It's our hope that doctors in the future will be able to use AI to select successful medical therapies for patients with ulcerative colitis and Crohn's disease. Artificial neural network also has been used to predict 1-year mortality with 90% accuracy in patients with cirrhosis. This might help us with liver transplant evaluations in the future. We can also use AI to predict prognosis after thermal ablation of liver cancer. With the help of AI in liver cancer, we can predict curative potential by employing transarterial chemoembolization. AI can also be used to improve the diagnostic capabilities of endoscopic ultrasound, or EUS, which is a kind of ultrasound probe attached to a scope to detect pancreatic cancer and intraductal papillary mucinous neoplasms. AI has also been used to help gastroenterologists detect pancreatic cancer based on both endoscopic ultrasound and serum markers. It's our hope that in the future, artificial intelligence may help us detect pancreatic cancer in earlier stages and help us save patient lives. Oncologists can now use endoscopic ultrasound with AI technology to provide additional information about rectal cancer before surgery and to improve treatment. The FDA has developed regulatory plans for quickly evaluating and approving updates and modifications to AI software technology. AI software producers will be able to update software for scopes, ultrasound, CT, MRI remotely and instantaneously via Wi-Fi, just like our iPhones and smartphone devices constantly update today. Now here's something really cool. Artificial intelligence can now help us monitor patients from home, the holy grail of medicine. For example, we have the capability to measure fecal calprotectin, an inflammatory marker in inflammatory bowel disease patients, using smartphones, which could help us better recognize the beginnings of flare before a patient even feels sick and allow physicians the opportunity to intervene earlier. This is an incredibly exciting and revolutionary time within gastroenterology. Technology advances in imaging capability and computing power are synergistically allowing us to detect precancerous lesions and cancer more easily while performing endoscopy. Gastroenterologists are ready to embrace these emerging technologies as they become ready for prime time clinical use.